Now see the part 2 of gravitation. Right. So next question is third one. So a body weighs 72 Newton on the surface of Earth. So this is the Earth. A body is lying over it. So its weight is given, that is 72 Newton. Right. So what is the gravitational force on it at a height h? So you have to find the gravitational height h. Right. Height is equal to half of the radius. So h is given as r by 2. So look at the question number third explanation. So weight we defined as mass into acceleration, right? So at a height h above the surface of Earth, weight will be given as. So it is given as F equal to mg divided by 1 plus h upon r whole square. So mg value we know, right? This is your mg. So it is 72 Newton divided by 1 plus h upon r whole square. Right. Now put instead of h r by 2. Then you will get 72 Newton divided by 1 plus r by 2 into r whole square. So it is coming out to be this r and r get cancelled. 72 divided by LCM is 2. So it is 2 plus 1 upon 2 whole square. So if it's nothing but it is equal to 72 divided by 3 whole square into 2 whole square. So it is 72 into 4 upon 9. So it is cancelled with 8 times. So force is 32 Newton. Right, it is asked in 2020, page 2. Now see the question number, fourth one of gravitation. So fourth is, what is the depth at which value of acceleration due to gravity become 1 upon n times that of the surface of the Earth? So value of acceleration, you have to find that 1 upon n times of the g. So at what height or depth? This is asking about depth, right? So let's see. So depth change in acceleration is given as g dash is defined as g into 1 minus d upon r. Right. So g dash is given as g upon n times. So put here instead of g dash, so it is g by n is equal to g into 1 minus d upon r. So this g and g will get cancelled. So it is remaining 1 upon n is equal to n minus 1. No, 1 minus 1, right? 1 minus d upon r, right? So you have to find d value, right? D value. So what will be d? It is 1 upon n. Take this one, take this part on right part. So it will be 1 minus 1 upon n is equal to, and this on right hand side. So it will become d upon r. So take the LCM, n minus 1 divided by n is equal to d by r. So d is coming out to be, take r here in this numerator, then it will be r into n minus 1 divided by n. So this is the relation between d and r and n, right? It is asked in 2020, again phase 2. So let's see the next sum, that is fifth one. So fifth one is talking about a body weight is given, that is 200 Newton. On the surface of Earth, how much will it weight half away down the center of the Earth? So what will be the weight when it is coming down to half of the Earth, r by 2? So for that we apply depth formula again, d dash is equal to g into 1 minus d upon r, right? So this is the force again. So you have to find force, right? So you can multiply both side by m. So it will be m g dash is equal to mg into 1 minus d upon r. So mg value we know, right? 200. That is 200 into 1 minus d we know, that is r by 2 we have to go, right? So it will become r by 2 into r is equal to mg dash. So this is the F dash formula. So it will be 200 into, or it is written as weight. So it R and R get cancelled. So it is 1 minus 1 upon 2. So it will be 200 into 2 minus 1 upon 2. So it is 100 into 1. So weight is your 100 Newton coming out. Now see the next part, that is sixth one. Sixth one is talking about work done to raise a mass m from the surface of Earth to height h. So there is a mass of object having a small m from the surface of Earth, right? We are raising. This is the radius. From here to here, we are taking it down, up, right? So what is the change in energy? So let's see. So as we know, initial potential energy is given by minus of Gm m upon R. So your final potential energy will become minus Gm m upon 2 of R. Right? So change in work done is change in potential energy. So we know that relation also. So relation is work done is equal to change in potential energy. Change in potential energy. Work is equal to UF minus UI. So it is given by, so please solve it down. So it is minus Gm m upon 2R minus of minus Gmm upon R. So it is relation is 2R. Right. So this will become 2 coming here with plus, right? So it is minus of Gmm plus 2 Gmm. So it is coming out to be Gmm upon 2R, your final work done. Now you can put like Gm as mg. As we know, Gm equal to Gr square. So you can put for the reduced form. So it will be mg R upon 2 after putting. If you want to see, then you can see the explanation also. So W is equal to, instead of Gm, I am putting Gr square. So it is Gr square into a small m upon 2 of R. So 1 R will get cancelled. So remaining is this part. No? So this is the final answer. You can write it down. Now see the question number 7. When a block of mass M is suspended by a long wire of length L, right? So this is the long wire length L. Mass M is suspended through it. Capital M is given, right? So length of the wire become L minus L, the elastic potential energy in the extended wire. So there is change or reduction in the length. So it is given by L minus of a small l. So mass will be the same. So you have to find the change in elastic potential energy, right? So as we know, the formula elastic potential energy is given by, or U is given by, it is 1 upon 2 work done due to gravity. Work done by gravity. So it is given by U equal to 1 upon 2 mg L. So this will be the formula, right? There is a small change in length, right? That's why we have taken small L only. Now see the question number 8. So 8 is talking about kinetic energy of planet in an elliptical orbit at the position ABCD. So there is diagram given to you. So this is elliptical path. This is point A, this is B. This is perpendicular S, this is C. Right, so you have to tell the AC is the major axis and XB is the perpendicular to AC at the point S as shown in the figure. So you have to tell the relation between K, KB and KC. Asked in NEET 2018. So let's see the explanation, 8th one. So in the diagram, we analyze that point A is perihelium. So this point is called as perihelion. Perihelion. Right. While C is at Aphelion C is called as aphelion. Right. So velocity will be VA is more velocity than VV than VC. So this is the relation between them. And as we know, kinetic energy is 1 upon 2 mv square. So kinetic energy is directly proportional to velocity square. So whose velocity is more, kinetic more energy is also more. So K energy is ज़्यादा as compared to KB then KC. So this is the relation between them. Now see the question number next one that is asked in ninth one. It is asked in NEET 2018 again. If the mass of the sun were 10 times smaller, right? Mass of the sun is 1 upon 10 times smaller than the initial. Then the universal gravitational constant were 10 times. Gravitational constant will be 10 times of that one. Large in maximum. Which one is not correct? So this talking about correct, incorrect statement. So G on the earth will not change. So this will be the not correct statement. So when universal constant is 10 times larger G dash, which show that acceleration due to gravity increases, G dash earth will not change, right? So G dash is nothing but G of G. So this is again increasing, so acceleration has no effect on it. Not correct, right? So due to the G dash changes, so normal acceleration also changes, right? So option D is incorrect statement given to you. Now see the next part, that is 10th one. 10th one is acceleration due to gravity at height h, 1 kilometer. Height is 1 kilometer. Acceleration due to gravity at height h, 1 kilometer of the surface of the earth, right, as the depth below. So depth and height is same we are taking. So acceleration due to gravity above the surface earth, G test is equal to G into 1 minus 2h upon RE. So this is the above the surface G given to you. Right, we show delta D is D into D upon RE. So this is the reduced form of first one only, which is due to gravity below the surface of Earth. So this is the above the surface, next is below the surface. So it is given by G dash is equal to G into 1 minus D upon of R. So it will be G dash will become G into 2H upon RE, right? So we can see that so your D, so comparing these two, you will get what? If you are dividing, you will get this and get cancel, G and G get cancel, RE and RE get cancel. So D is equal to 2H, right? So you can get 2 into 1, height is 1, right? 1 kilometer is given there. So your depth will be become 2 times 2 kilometer. It is asked in 2017. Now see the question number 11. Starting from the center of the earth having radius r, acceleration g is shown by. So acceleration due to gravity is given by g is equal to 4 by 3 pi. Density g r. R is less than r. Next one is given by 4 by 3 pi density g r cube upon r square. R is greater than capital R. So this is the g given to you, right? Now see the next formula. So just remember the formula. So you will get the B option, right? So above the earth surface first increases, then it decreases. So this is for the first one. this part, and this is for the second. So this is first one is increasing graph. So this is your increasing graph, and this one is your decreasing, right? So first A increases, then it decreases. This is the relation between G and R.